Welcome to Section 7, Chapter 2 of our Algebra course hosted by Iridium Tutoring. Today we'll be talking about absolute value equations and just a brief introduction to them. This is the last section in Chapter 2. Absolute value, geometric definition. The notation for absolute value of P is absolute value of P. Absolute value of P is the distance of the number from the origin, 0, of the number line. Distance will always be positive. Here is the origin, and this is what a number line looks like. Absolute value of 6, meaning 0 to positive 6, is equal to 6, a distance of 6, because the distance of 6 from the origin 0 is 6. And then absolute value of negative 6, meaning 0 from to negative 6, is equal to 6 because the distance of 6 from the origin is 6. Or the distance from negative 6 to the origin is 6. So in conclusion, from both points to the origin, the distance will be 6. Absolute value definition, mathematical. The absolute value of P can also be described as this. If P is non-negative, absolute value of P is P, meaning P stays the same. If P is negative, then absolute value of negative P is P, because it would become the opposite, so P becomes positive because distance is always positive. From this, we can conclude that the absolute value of a number will always be non-negative. Here are some practice problems. I want you to pause the video and work through them. Here are the solutions to those practice problems. Absolute value equations. In general, given an algebraic expression x and positive number p, if absolute value of x equals p, then x equals negative p or x equals p. In other words, the absolute value of x can either be positive or negative p, as we determined from our number line and distance slideshow. Example, solve absolute value of x plus 2 equals 3. So x plus 2 equals 3, or it equals negative 3. So you have to solve both of these equations to satisfy this main equation. So the solution will be x equals 1 through this way, and actually it will be x equals negative 5 this way. And both answers are correct. Graphing absolute value equations. Absolute value equation lines will always form a V shape, when plotted on a graph. They are in the form f of x equals a times absolute value of x minus h plus k. This is the equation for most absolute value equations and the ones that you have to graph, where a determines the slope of the v, along with if it opens up or down. We will talk more about opening up or down later. Where h determines if the v goes right or left. So if this is the original v, h determines if the v goes right or left. And k determines if the v goes up or down, meaning if this is the original v, k would determine if v would go up or v would go down. But the shape of the v does remain the same. It's just all determined from k. Example, f of x equals 2 times absolute value of x minus 1 plus 3. A determines slope, so the slope of both lines is 2, meaning this line and this line. These are technically two separate lines. A positive slope means the v opens up. A is the slope and it's positive 2, meaning that the v will open upwards, meaning a normal v as seen here. The vertex, which is the point where both lines intersect, is determined minus h comma k. So if you remember, h is this and then k is here. So minus h would be 1 comma k, which is 3. So you know that the vertex will be at 1 comma 3. So on this graph, you go over 1 and then up 3. 1, 2, and 3. In this example, negative h is 1 and k is 3. So the vertex is 1 comma 3. Note, the vertex is either the highest point or the lowest point in an absolute value graph. So in this case, the vertex is the lowest point in this graph. Another example, f of x equals negative 1 times absolute value of x minus 1 minus 1. A determines slope, so the slope of both lines is negative 1. A negative slope means that the v opens down. So this is a normal one, but since the slope is negative, it has to open downwards, like as seen in this graph. The vertex is determined by minus h comma k. In this example, minus h is 1 and k is negative 1 because h is negative 1 and negative 1 is just positive 1. And then k is negative 1 right here. So the vertex is 1 comma negative 1 as seen here. Note, the vertex is either the highest point or the lowest point in an absolute value graph. So in this case, the vertex is the highest point because it opens downwards. Here are some practice problems. Without plotting, I want you to find whether the v opens up or down. Here are the solutions. Find the equation of this graph from what we have learned. Solution. Remember, f of x equals a times absolute value of x minus h plus k. How do you solve this? The vertex is minus h comma k, which is negative 4 comma 5 if you look at this graph. Negative 4 comma 5. Plug into equation as plus 4 and plus 5 because this is going to be negative h, but we want to make this into the normal h that goes into the equation. So you have to do negative h again for this. So this would be plus 4, and then h would be plus 4, and then k would be plus 5. Then we can see that the v opens down, so slope is negative. So whatever slope you get at the end must be negative. Then we can figure out slope by rise over run, which is 1 upon 1. So slope has to be negative 1 because we found the slope is 1 and we know that the slope has to be negative, so it's -1. If you put all those instructions together, you get f of x equals minus, and this is actually supposed to be a 1, but you can just say minus 1 times absolute value of x plus 4 plus 5. That's the end of this session. Thank you for tuning in to Chapter 2 of our algebra course hosted by Iridium Tutoring. We hope to see you stick around for Chapter 3. I'll see you later. Bye.